Hi, so this video is to show the mastery of Objective 9.1, which is real systems versus point particle system. So I chose question 9P44, and this question has two parts, A and B, and each part asks for us to ask for our analysis of a system of two blocks connected by a spring and being pulled by a hand, um, the context of both point particle and real system. So in A, if we consider that in a point particle system, we can define the system as just a point particle that has a mass of 2m, because one block is weighs mass has the mass of m, and the surroundings therefore would be the hand that is exerting a force on the point particle Fn, the contact force, and also the earth, which is also exerting a force on the point particle. And in this system, we only analyze the change in K trans. So we could say that the delta K trans equals the work that's been done on the point particle, which is, if you look at this free body diagram, because there is a gravitational force pulling it downward with the force of 2 mg, and then a Fn force pulling it upwards with 167 newtons, and it says in the question that it's bigger than 2 mg, so it's the arrow is bigger than the fg. So therefore work equals, I mean, it looks like omega, but it's really work, equals force times the distance, and the force is 167 minus 100, because 2 times 5 kilograms times around 10 kilograms per newton, or newtons per kilogram, is 100. And for D, to plug in D, we find that we find the distance that the center of the mass of the system moved. And this first part of the equation, y1f plus y2f divided by 2, is the center of mass in the final state, and this part is the center of mass in the initial state. So if you subtract that, you get 0.35 meters. Therefore, delta K trans equals 16.7 newtons times 0.35 meters, which equals 23.45 joules. And for part B, we take a look at the real system. And the system is still the two blocks. We just don't identify it as point particle. The surrounding is still hand and earth. But this time we not only consider the change in K trans, but also consider delta K relative, which in this case includes vibrational force as well as the spring vibrational kinetic energy as well as the spring potential energy. So we already know delta K trans from part A, and the question asks us to just calculate this as a whole, not individually. So we just leave it in this form for now, and the work is the same, the force is the same, but in the real system, since we analyze not the center of mass, but how the point of contact moved, that's just y2f minus y21, which is 0.5 meters. So therefore, if you do the algebra, the total change of K vibrational and spring potential energy is around 10.05 joules.